and welcome back. Today we are going to see and explore the most powerful ideas in operations research, duality. Now, if linear programming helps business decide what should we produce, then duality help answer what are our resources actually worth. By the end of this lecture, you'll understand what a dual problem is, why shadow pricing matters, how business use duality in real decisions, and how to interpret resource value strategically. And don't worry, we will avoid complicated theories at first and focus on practical business understanding. Before we start, if a factory has one extra labor available, do you think that extra hour has value? How would a company estimate that value? That exact idea leads us directly into duality and shadow pricing. What is linear programming? As a refresher, linear programming or LP is a mathematical technique used to make the best possible decision when resources are limited. Businesses always face limitations. Limited labor, limited machine, limited budget, limited raw materials, limited production time, and so on. So, the big question becomes, how do we use limited resource most efficiently? For example, imagine a bakery. They have limited flour, limited sugar, limited workers. The bakery must decide how many cakes to produce, how many breads to produce while maximizing total profit. That is exactly what linear programming solves. The linear programming focus on maximizing profitability, direct product toward highest lead, minimizing expenditure, keep production cost and input low, and resource stewardship, save critical time and operations capacity. Now, here's something fascinating. Every linear programming problem secretly has a second hidden version called the dual problem. Every linear programming problem has two perspectives. The first, the primal problem. This is the original business problem. Instead of asking how many products should we make, it asks how valuable are the resources we are already having. This is why duality is so powerful. It transforms production decision into resource valuation decision. In simple analogy, think of the primal problem as running the factory and the dual problem as evaluating those of the factory's resource. Which do you think executives care more about? Product quantity or resource value? Actually, they need both. Let's make this more concrete with a furniture company example. Imagine a furniture company producing tables, chairs, and the company has limited wood skilled labor. Now, the primal problem asks, how many table and chair should we produce to maximize total enterprise profit? And the duality question asks, what is the true underlying economic value for our wood and labor resource? Instead of focusing on products, we focus on bottleneck resource. If labor is extremely scarce, the labor becomes highly valuable. If wood is abundant, its economical value may be lower. Duality helps managers identify critical bottleneck, high value resource, investment priority. Which resource do you think is usually more valuable in modern business? Do you think it's machines? Do you think skilled labor? Do you think time? Do you think data? Now let's compare the primal and dual problem side by side. Here is the key difference between the primal and dual perspective. The primal problem focuses on products, production level, profit maximization, and the main question is, what should we produce? The dual problem focuses on resources, constraints evaluation, constant cost minimization, and the main question is what are our resources worth? The amazing thing is both problems are mathematically connected. Solving one automatically gives information about the other. A student often think duality creates a completely different problem. But actually, the dual is simply the mirror image of the original linear programming. Let's test understanding. Suppose a company has plenty of warehouse space but very little labor. Which resource likely has the highest shadow pricing? Why duality is important? Duality gives managers strategic intelligence. Instead of guessing, it quantifies resource importance. Here are three major business benefits. The first one, evaluating bottlenecks. Duality identifies which resources limiting profitability. For example, a factory may discover labor is a real bottleneck, not raw material. The second importance is informed procurement or smarter procurement. Managers can determine whether buying more resources worth the cost. Example, should we pay overtime wage? Should we rent more warehouse space? Duality help answer that mathematically. The third importance is strategic agility. Businesses operate in changing environments. Duality help firms react quickly. When costs change, supply change, market demand change, duality help firms react quickly. Real life example, Amazon, airlines, hospitals, and manufacturing companies all use optimization and duality concept behind the scene. If you were managing a factory, which resource would work you most losing suddenly? Let me repeat that. If you were managing a factory, which resource would worry you most losing suddenly? Now we arrive at one of the most important concepts in duality, shadow pricing. Shadow pricing is one of the most practical ideas in operations research. A shadow pricing tells us how much additional profit can be earned from one extra unit of a resource. For example, if the shadow price of a labor is $15, that means one additional labor hour increased profitability by exactly $15. That's incredibly useful for managers. It immediately tells them whether extra labor is worth purchasing and the maximum price they should pay. Imagine a restaurant kitchen. During peak hours, one extra chef may allow faster service, more customers, more profit. That extra chef has economic value shadow price measure that value. But shadow prices are not always positive. That depends on whether constraints are binding. I'll repeat that. In most final exams, this question raised once in different sections. Shadow prices are not always positive. It depends on whether constraints are binding. Shadow pricing follows an important rule. The, the first one is, or the first case is, binding constraints. Shadow pricing follows an important rule, the binding constraint. The binding constraint means the resource is fully used, there is no leftover slack. In this case, shadow price is positive. Why? Because more of that resource would increase profit. The second case is non-binding constraint. A non-binding constraint means some resources remain unused. In this case, shadow price equals 0. If you ask why, because extra units provide no additional benefit. Suppose a company uses all labor hours but only half of its warehouse space. Then labor has value, warehouse expansion adds no benefit. So labor shadow price is greater than 0, while warehouse shadow pricing equals to 0. Now let's apply duality to a full business case study. Meet Dakota Furniture Company. Dakota produces desks, tables, chairs. Like every manufacturer, Dakota has limited resources. Their major constraints are lumber, finishing hours, and carpentry hours. The company goal is simple: maximize total profit. This case is important because it demonstrates how linear programming and duality work together in a real manufacturing setting. Imagine you are the operations manager. Every day you must decide what product to prioritize, which resources are more valuable, whether overtime is worth paying, and so on. If you own this company, which resource do you think become the bottleneck first? Let's examine the actual production data. As you can see it here, the production information, each product consumes different resource. For example, desk use 8 units of lumber, 4 finishing hours, 2 carpentry hours to make a profit of $60. Table and chair also use different resources to get a different profit. Now the challenge is, how do we combine this product to maximize total profit while staying inside resource limit? Notice something important. The product with the highest profit is not always the best choice. If you ask why, it's because it may consume too many scarce resources. Which product seems most resource intensive for you guys? I want your answer in comment section. To model this mathematically, we first define decision variables. In linear programming, we convert real-world products into mathematical variables. So we use x1 or variable 1, the number of desks produced, variable 2 as x2, the table produced, and x3, the number of chairs produced. These are called decision variables because they represent decisions management controls. Everything in linear programming starts with variables. A student often asks, why use variables? Because mathematics needs symbolic representation before optimization can happen. If x1 is equals to 5, that means the company produces 5 desks. If a company makes 4 products instead of 3, how many decision variables would we need? Now let's build the actual optimization model. Now we create the primal linear programming model, which is the objective function having the objective to maximize total profit. So we multiply profit per product by number of units produced, constraints, and next we add resource limitation. The objective function answers what are we trying to optimize. The constraint answers what limit us. In real life, can business optimize profit without constraints? But now comes the fascinating part, building the dual problem. To build the dual, we shift focus completely. The primal focus on products, now the dual focus on resources. We assign variables to each resource. We can use variable y1 for the value of lumber, y2 for the value of finishing hours, y3 for the value of carpentry hours. These are called dual variables. Instead of maximizing profit, we now minimize total resource valuation. Think of this way. The primal asks, how should we use resource? The dual asks, what are the resource words? This is one of the most elegant ideas in optimization. Products become constraints, constraints become variables. Why might investors or buyers care about resource value instead of production plan? Let's now see the complete dual formulation. In the dual problem, our objective changes. Instead of maximizing profit, we minimize the total implied value of resources. The constraints now ensure resource pricing must be high enough to justify product profits. This guarantees consistency between product profitability and resource valuation. If resource prices are too low, then theoretically, someone could buy resource cheaply and generate unfair profit. The dual prevents that imbalance. Imagine valuing a restaurant. You could value menu sales or the kitchen equipment, the labor, and the facility. Duality links both perspectives mathematically. So, what is the economic meaning of the dual in real business? The dual has a very practical economic interpretation. This can be one of the questions that you will find in your final exams. Imagine an outside investor wants to purchase Dakota resource. The question becomes, what is a fair value for lumber and labor? The dual problem answers exactly that. It calculates fair internal resource valuation. This matters in merger, acquisitions, outsourcing, procurement negotiation, capacity planning. If a labor has extremely high shadow value, management way, hire more workers, automate process, prioritize labor efficiently. If skilled labor suddenly become rare in the market, what do you expect happen to its shadow price? Probably it will increase, right? Now we reach one of the most beautiful results in optimization theory, the absolute symmetry. At optimal conditions, something remarkable happens. The primal and dual product the same optimal value. In this example, maximum profit from production is $280, minimum resource valuation is $280, exactly equaled. This is called a strong duality. So you are expected to define what it means by strong duality in your exams. A strong duality means the production side and the resource valuation side perfectly agree. This tells us the system is economically balanced, no hidden profit opportunity remain, no resources under or overvalued. This equality is not a coincidence. It is one of the foundational theorems in linear programming. Why do you think equality is important for business confidence and decision making? Write your answer in your comment section. Now let's wrap up the duality section before moving to sensitivity analysis in the next video. So far, we have learned that every linear programming problem has a dual problem. The primal focus on the product, the dual focus on resources, shadow pricing measure resource value, bring in constraints, create economic value. Duality help a business make smarter strategic decisions. Most importantly, duality transform optimization from what should we produce into what are our limited resources truly worth. That shift is incredibly valuable for real organizations. If you were managing a business, which would you rather know? The best production plan or which resource create the most value? The answer is usually both. and duality connects them together. If this lecture helps simplify duality for you, make sure to like the video, subscribe, and share it with classmates. Studying operation research. In the next session, we will explore sensitivity analysis and learn how business respond to changing market conditions without rebuilding their optimization models from scratch. Thank you for watching.